Hello everyone! So for this video, we will discuss about the lesson 2, that is the review on linear inequalities. Inequalities, like the more familiar equations or relationships expressed in mathematical form. Although less familiar than equations, inequalities are frequently used in solving business problems which cannot be expressed in the form of equations or those which call for minimum or maximum requirements. So, inequalities in terms of solving is just like equation. But what is the difference between equation and inequalities is that equation, from the word itself, that means equal. So both sides of the equation, whether it be the left expression or the expression in the right side of the equation, so both shall be equal in value. Unlike inequalities, okay, so it shows a non-equal sign. Okay, it shows non-equal sign, and of course the two sides of the inequalities are not equal. So inequalities are used when a problem calls for minimum or maximum requirements. So that means that in this case there will be no unique answer, because there will be just a given limit. So let's say the answer should be less than 1, or the answer should be more than 1. Okay, so that is inequality. Now, distinction between the two, okay, this is what I have just discussed, is that whereas equations use the equal sign, inequalities use any of the inequality symbols, which are less than, is more than, less than or equal to, greater than or equal to. Extra care, however, should be exercised in solving problems using inequalities, because the use of a wrong symbol would result a wrong answer. Okay, so you should take note about the rules in solving inequalities. You take note about the signs that is to be used, because again, using wrong sign will give us wrong answer. Now let us start with solving inequalities in one variable. An inequality is a statement formed by placing an inequality symbol between numerical or variable expressions. Here are the two inequalities. For example, 5 is greater than negative 2. That is an inequality, and that statement is true. 3x plus 5 is less than or equal to 11. So this is also an inequality, but in this inequality, there is a variable in which we still have to look for. Now, here we have 5 is greater than negative 2, and the product of 3 and x added to 5 is less than or equal to 11. Now, equivalent inequalities. How do we solve equivalent inequalities? Now, let's answer example 1. Solve 8 multiplied by x minus 3 plus 1 is greater than 3 multiplied by 4x plus 7, and graph its solution set. So here is the solution. First, we have 8, of course, the formula itself, or the inequality itself, we have 8 times x minus 3 plus 1 is greater than 3 times 4x plus 7. 8x, so that we got that by 8 multiplied by x, and then minus 8 multiplied by x, that is 8x, and then of course 8 multiplied by 3, that is negative 24. Now next, plus 1 and then greater than, we have 12x. How did we get the 12x? That is 3 times 4x, we got 12x. And 3 times 7, that is 21. So just like how you solve the equation, that is also how you will solve the inequality. And then we have negative 24 plus 1, that is negative 23. Okay, and for this side, that is just the same. Now, again, we have to put those we have to put those that have the same variables, and we have to put together those that have the same variables and those that do not have any variables. So those are the constants without any variables. So 8x and then minus 12. So of course, if the 12x is positive from the other side, when you transfer it to the opposite side, it will become negative. And just like 23, from negative 23, that is to positive 23. Now next, we have 8x minus 12x, we got negative 4x. And then 21 plus 23, that is 44. And divide both sides by negative 4 for us to get negative 11. Now as you can see, our symbol here has changed. Okay, so why did it change? So take note of this, class. So if you're gonna divide if you're gonna divide an inequality with a negative sign, it is necessary to change the sign or transfer it to an opposite sign. So just like this one, because we divided our inequality by a negative 4, then from greater than, it will now become less than. So for our answer, that is x is less than negative 11. Now to check, class, whether our answer is correct, now take note that as you can see here, x must be negative 11 for it to satisfy our inequality. Now what are the numbers that is less than negative 11? So that is negative 10, negative 9, negative 8. I'm sorry, negative 11 less than negative 11, that is negative 12, negative 13, negative 14. So, you must get an answer, or you must get a number that is less than negative 11 for it to satisfy our equation. Any number that is negative 11 or greater than negative 11 will never satisfy our inequality. Now, to check, we are gonna use negative 12 because of course negative 12 is less than negative 11. Now we will substitute x by negative 12. So we now have 8 times negative 12 minus 3 plus 1 is greater than 3, and then 4 times the negative 12 that we substituted plus 7. Now to answer, we will answer first those that are inside the parentheses. So negative 12 and negative 3, that is negative 15. And on the other side, we have 4 times negative 12, that is negative 48, and copy the rest of the numbers. Then next to answer, we have 8 times negative 15, and then we get negative 119 plus 1. And then for the other side, we have negative 48 plus 7, and then multiplied by 3, and then we get negative 123. Now take note of our statement, that is negative 119 is greater than negative 123. So class, if based on our checking, the statement that will come up is true, then that means that the number that we substituted did really satisfy our equation. So as you can see, this is true, right? Negative 119 is greater than negative 123. And so therefore, negative 12 satisfied our inequality. Now class, what if we try 1? So let's say that x is equals to 1. So as we all know, 1 is higher than, or 1 is greater than negative 11. So since what we needed for x is less than negative 11, and so therefore 1 will surely not satisfy our inequality. But to just check whether 1 will really not satisfy our inequality, let us try to substitute 1 with x, and then let's see if the statement that will come out is true. Now we have 8 times x minus 3 plus 1 is greater than 3 times 4x plus 7. Now to substitute x with 1, we have x as 1. Okay, and for here we have 4x, so x must also be 1. Now here we have 1 minus 3. Okay, and so we have 1 minus 3, that is negative 2. Multiplied by 8, we get negative 16 plus 1. And then here we have 4 times 1, that is 4, plus 7, that is 11. And so we got 11. Now to finally solve the inequality, negative 16 plus 1, that is negative 15, and 3 times 11, that is 33. So as you can see, what came out on our statement is that negative 15 is greater than 33, which is actually not true, right? Because 33 is greater than negative 15 instead. Now, since this statement is false, so therefore, it is a proof that 1 will not satisfy our inequality. Because as you can see, what will satisfy our inequality or what will serve as x are those numbers that are less than negative 11. Even if you try the amount negative 11, it will not result to a true statement because what we needed is less than negative 11. Okay? Now, let's proceed to example 2. So, I have here the second inequality. 5x is greater than 5 multiplied by x plus 5. So, we have to distribute 5 times x, that is 5x, and then 5 times 5, that is 25. Now, to answer this one, 5 must be transferred to the other side, leaving the 25. Okay, so this is now 5x minus 5x is greater than 25. So, what will happen to this? Instead of finding x, as what you can see, since we deducted 5x by 5x, the answer will now be 0. Now, since the answer is 0, and then we will copy the 25, so what will come out is that 0 is greater than 25. So, if this is just a normal inequality, just like what we answered earlier, so this must be like x is greater than or less than a number. But as of this item, our x was cancelled, right? So it is now 0. Now what will happen to this type of inequality is that if what will come out after finding x is a negative statement, then that means that there is no solution for this inequality. So what does it mean? It means that any number that you substitute with x will never satisfy the equation. In other words, there will never be a number that will satisfy the equation. Okay, that is if what will come out is a false statement. So as you can see, 0 is greater than 25. So that is false, right? So therefore, there is no solution. Even if you substitute a positive number, a negative number, a fraction, a decimal, a percent, no number will ever satisfy our inequality. Okay? So, in that case, we will just put the word no solution. Okay? This is also in the case of the equation. Okay, if you answer the equation and what will come out after you answer the problem is, let's say, 0 equals to 25. So, as we all know that 0 is not equal to 25. So, therefore, that statement is false, and so it only means that it has no solution at all. So, just put it there, no solution. Okay, now since the inequality 0 is greater than 25 is a false statement, the inequality has no solution. Okay, now let's try the example 3. 8x is less than 8 multiplied by x plus 2. So we will we just have to distribute 8 times x, that is 8x, and 8 times 2, that is 16. Now, as you can see, if we transferred 8x to the other side, that will become 0. And then leaving 16 on the right side. So, what is the result is that 0 is less than 16. Now, since this is a true since this is a true statement, then that only means that any real number that you substitute with x will always satisfy our inequality. So that means that it is the opposite of our example 2. Now, since what came up with example 2 is a wrong statement or a false statement, then this only means that there is no solution for this inequality. But for number 3, since this is a true statement that 0 is really less than 16, then any number that you substitute with x will always satisfy our equation. Since the inequality 0 is less than 16 is a true statement, the inequality is satisfied by every real number. Therefore, the solution set is R. Okay, so when you encounter this problem, you just have to put any real number, or you will put SS or solution set colon and then R, that means real number. Okay, so that means that again, even if you put 1, 2, 3, 4, 5, negative number, positive number, fraction, whatever number, whatever real number that you substitute with x, it will always satisfy our equation. Inequality rather. Okay? Now that is for equivalent inequalities. Now next, solving problems involving inequalities in one variable. Phrases such as is at least and no less than can be translated into mathematical terms by using the symbol greater than or equal to, and phrases like is more than and is at most can be translated by using the symbol less than or equal to. So take note of this, that if the problem says is at least or no less than, that means the number must be greater than or equal to. But if it says is more than and is at most, then that means that the number should be less than or equal to. Now we have here the example. The cost of a 14-inch color television is no less than 5,000, or the cost of a 14-inch color television set is at least 5,000 pesos. Okay, so that means that the amount or the cost of the television set will not be less than 5,000. So that means that it should be greater than or equal to 5,000. Okay, is at least 5,000, so that should be greater than or equal to 5,000. So the symbol that we are gonna use is the greater than or equal to symbol. So that would be stated as in symbol C is greater than or equal to 5,000 pesos. Now next, the price or P of a brand new computer is at most 50,000 pesos. So this means that 50,000 pesos is already the maximum. Okay, that is at most. So this means that the price should be less than or equal to 50,000 pesos. Now in symbol, we have P is less than or equal to 50,000 pesos. And for number 3, a factory a factory can only produce no more than 200 items a day. So no more than 200 items. So this means that 200 is already the okay, 200 is already the maximum. Okay, so let me just correct this one. So this should be no more than. Okay, is no more than or is at most. Okay, so just add there is no more than and is at most. Okay, so a factory can produce no more than 200 items a day. So that means the 200 is already the maximum, and so the number should be less than or equal to. So in symbol, x must be less than or equal to 200 because again 200 is already the maximum. Okay, so that is solving problems involving inequalities in one variable. Now, let us try this example. Peter is 3 years older than Diane. 20 years ago, Peter was at least twice as old as Diane was. At most, how old is Diane? So, the problem says that currently, Peter is 3 years older than Diane. But 20 years ago, the age of Peter was twice from the age of Diane. So the question is, at most, how old is Diane today? Okay? Now, for us to easily solve the problem, let us make this table. So we have here the person, their present age, and their age 20 years ago. So we have Peter and Diane. Now, since the question is how old is Diane, so the age of Diane must be the x here. Okay? So let x be the age of or the present age of Diane. Now, since the problem stated that Peter is 3 years older than Diane, so x must be plus 3 to get the age of Peter. Now, if we are to make the expression of their birthday 20 years ago, so we just have to deduct the number 20. Now for Peter, x plus 3 minus 20, so that would now be x minus 17. And for Diane, that is still x minus 20. Now, what is the equation and solution? X minus 17, okay, here it is greater than or equal to x minus 20. Okay, but take note that accordingly, since Peter was at least twice as old as Diane, so we are gonna multiply the age of Diane by 2. Okay, for it to be greater than or equal to Peter. Okay, so we must multiply it by 2. So this is the age 20 years ago, x minus 20. And then to be equivalent with our first equation, so we must multiply it by 2. Okay, so this is an equivalent inequality. Okay, so since accordingly, the age of Peter is twice as old as Diane, so this one, the age of Peter 20 years ago is equivalent to the age of Diane, which is x minus 20 multiplied by 2. Because as you can see, it should be at least twice as old as Diane was. Now, after this one, you simply have to compute. Now, we have x minus 17 is greater than or equal to 2 times x, that is 2x, and then 2 times negative 20, that is negative 40. Now, next, we just have to group all those that have the same variables. So this is now actually x minus 2x. If we transfer the 2x from this side to this side. So x minus 2x, of course, that is negative 1x, or for short, that is only negative x. And for the other side of the equation, we have negative 40. If we transfer the negative 17 here, it will now become negative 40 plus 17. Now to solve, that is negative 23. And then we have to divide both sides by negative 1. Now take note as what I have said, if we are gonna divide the inequality with a negative number, then the symbol will be changed to its opposite symbol. So from greater than or equal to, it will now become less than or equal to. So negative 23 divided by negative 1, that is 23. So class, this means that the age of Dayan should be less than or equal to 23 for us to satisfy this equation. Okay? So we must find a number that is 23 or less than 23 for for the equation to be satisfied. Now, again, Dayan is at most 23 years old now. So this means, class, that if we are to assume that Dayan is 24 years old, so it will not satisfy our equation because the age of Dayan should be at most or at a maximum of 23 years old now. So again, as I've said, the 23 is not the unique answer here because we are only we can substitute any number that is less than 23 too. Okay, so that's why it is stated Dayan is at most 23 years old now. So this means that even if you use 22, 21, 19, 18, 17, we are still or we can still satisfy the inequality. Okay? Now class, if you're gonna check this one, so just please check it on your own. Okay, you substitute 23 or any number that is less than 23, and then you will then get the answer. Okay? So class, if you're gonna okay, so let us substitute it. Let us substitute it right now. So since x is 23, so this means that in present, the age of Dayan is 23. So 23 plus 3, the age of Peter now is 26. Now how about 20 years ago? So if we're gonna deduct that one, 26 minus 20, that is 6 years old. And for Dayan, that is 23 minus 20, that is 3 years old. So that means that it is true that 20 years ago, Peter's age was twice as old as Dayan was, right? Since Peter was 6 years old 20 years ago and Dayan was 3 years old 20 years ago, then it is true that the age of Peter is at least twice of the age of Dayan. Okay? So that is for example 1. Okay. Now next, the sum of three consecutive odd integers is no less than 51. What are the integers? Okay. So again, the sum of three consecutive odd integers is no less than 51. So that means that 51 is already the minimum amount. Now, what are the integers? Now, let us assign x as our first integer. Okay? So, we're gonna find here three integers. But of course, for solution purposes or for our solutions here, of course, we are only to find x. Okay, so we can only find the second and third integer after we can find the x or the first integer. So let x be our first integer. Now class, since this should be three consecutive odd integers, then how are we gonna get the second integer? Okay, or how are we gonna create a formula for the second integer if the first integer is x? Now class, since in the even or odd integer there is a one number gap between them, so we only have to add 2 for the x. Okay? So, say for example, 1 is an odd integer. For us to get the second odd integer, which is 3, so we just have to add 1 plus 2, right? So, this means that x plus 2 is our second integer. Now, how about for the third integer? So, the third integer in the example that I have mentioned, so that is 1 plus 2, 3. And then the next integer there is 5. Now for us to get 5, we have to add again another 2 in our formula. So to sum up, x plus 2 plus another 2, that is x plus 4, and that is our third integer. But of course, what are we gonna put in our inequality here is only the, or I mean, what are we gonna find here is only the first integer, since first integer will serve as our x. And again, we can only solve for the second and third integer after we get the first integer. Now, how are we gonna make the formula? Now, since the sum of three consecutive odd integers is no less than 51, so we have to add all the formulas or all the expressions for the three consecutive odd integers. So x serves as our first integer, x plus 2 as the second integer, and x plus 4 as the third integer. So, since we have to get the sum, so we have to add everything. Okay? Now, is no less than 51. So class, the amount here should be no less than 51. So that means 51 is already the minimum. So that means the total of the amount here must be 51 or more. That is why we use the greater than or equal to sign. Now to compute, we have x plus 2 plus x plus 4 is greater than or equal to 51. Now, how did we get this one? We simply remove the parentheses, because even without the parentheses, we can still solve the expression. Okay? Now, x plus x, those are 3 x's. So that is 3x. And then 2 plus 4, that is 6. And then copy greater than or equal to 51. Now, to transfer 6, so 6 from positive 6, it will now become negative 6. So 3x is greater than or equal to 51 minus 6, of course, that is 45. And then, divide both sides by 3. And so, we got x is equals to 45 divided by 3, and that is 15. So as you can see, class, there is already no changing of symbol here, because the one that we divide for the both equation is a positive number. Unlike from our example 1, which is a negative number, in which case we change the sign to its opposite sign. But for example 2, the symbol remained. Okay, the symbol remained because this is not a negative sign. So this means, class, that our x must be greater than or equal to 15. So any number that you substitute with x, so that includes 15 or those numbers that are greater than 15, it will always satisfy our equation. So since x is 15, for example, since the x should be greater than or equal to 15, so let's try to see if x is 15. So that means the second integer is x plus 2, or 15 plus 2, that is 17. While the third integer is x plus 4, that is 19. So we now have our set of 3 consecutive odd integers. We have 15 plus 7 plus 19. Okay, so if you're gonna add this one, 15 plus 7 plus 19, how much is that? That is 51. So, 51 is greater than or equal to 51. That is true, right? Because we have the equal to. Okay. How about if we use other number here? It you can always use any other numbers to substitute x, so long as it follows our statement that x should be greater than or equal to 15. So whether you use 17 as x, so the First integer is 17, second integer is the second integer is 19, and the third integer is 21, it will still satisfy our inequality. Okay, so that is for example 2. Okay, now let's proceed to the other form of, or the other topic. Next, we have linear inequalities in two variables. So in the previous topic, or in the previous discussion, we discussed about linear inequalities in one variable. So as you can see, we only saw x there. Unlike in this topic, we are all ready to solve linear inequalities in two variables. How are we gonna solve this one? Now, the solution set of linear inequalities in two variables is a plane which can only be shown in a graph. It is the set of all solutions of the inequality. So, class, for the solution set, or the set of solutions in a linear inequalities in two variables, that is a plane. Okay? Now, of course, since a plane, we can only present the plane through a graph. So of course, we need to make a graph in the case of linear inequalities in two variables. Now, how do we do that? Let's try to solve example 1. Now, first, graph the linear inequality 3x plus 4y is less than or equal to 20. Now, first step, change the sign less than or equal to equal sign. Okay? We must change the less than or equal to equal sign to draw the boundary line. Okay? So the boundary line here, class, is the slope, which we already know. Okay? So in the case of linear inequalities, that is what we call boundary line, or we call that boundary line. Okay? So just simply change the inequality symbol to an equality symbol. Now next, graph the equation by finding the intercepts 0, 3, and 4, 0. Okay. Now class, so how did we get the 0, 3, and 4, 0? So this is actually the y-intercept and the x-intercept. So how do we get that? We already answered that, or we already discussed that from our previous topic. So for purposes of really knowing how to solve this one, so just try solving it on your own, and let's see if you got 3 as your y-intercept and 4 as your x-intercept. Now therefore, the boundary line will pass through 3 and 4, and it is a solid line because of the inequality symbol. Okay? So, class, take note that since this in this example the symbol is less than or equal to, so we must use a solid line. So what is a solid line? That we will know later. Okay, so class, since we already have our x and y intercepts, then we can already make our graph. But before that, using the origin 0, 0 as the testing point, okay, so class, we need to have our testing point here, because since, as I've said, our solution set here is a plane. Okay, what is a plane? Okay, so it is not only the line. Okay, it is not only the numbers, or it is not the numbers that lies on the lines of the graph, but rather it is a plane that is beyond the line. So that is why our line here only serves as the boundary, or it only serves as our limit, because there could be other possible answers or other possible numbers that can still satisfy our equation. Now, using the origin, let us test this one. So 3x plus 4y is less than or equal to 12. So let us substitute x as 0 and y as 4. So we can get 0 is less than or equal to 12, then that is true. So class, what is the purpose of this one? Because class, we have to draw our plane. Okay, we have to shade the portion which our for which the solution set, I mean, we have to shade the portion of the solution set in our graph. So that's why we have to test that since in a graph class, you have there in the middle 0, 0. So our plane will pass through the part of the graph which serves as our solution set. Now to test whether it will pass to the 0, 0 point, then we have to solve our linear inequality using the 0, 0. Now class, since the answer is here is true, then it only since the answer here is true, then it only means that our plane will pass through our origin, that is 0, 0. Okay, so therefore the solution is the region containing the origin. Now let us see to graph the linear inequality. So just remember this one. Okay, what we come up is a true statement using the 0, 0 as our testing point. Now here is our graph. For the x-intercept and y-intercept, so for the x-intercept we have 4 and for the y-intercept we have 3. So that is what we solve in our problem. Now let us make our boundary line. So this is what I mentioned as a solid line. Okay, so solid line, if the symbols are less than or equal to or greater than or equal to. Okay, so when there is an equal in our symbol, then we must use a solid line. Now, how about if that is only less than or greater than? So there is no equal in the symbol. Then in that case, we are gonna use a broken line. Okay, so what does it mean by having a solid line or broken line in our boundary line? So the solid line in our boundary line only means that aside from the sets of solution that is found within the plane, okay, when later we will make our plane, also the numbers that lie within this line will also satisfy our equation, because since this is our boundary, so let's say for example x is less than or equal to 15. So in that case, 15 could also satisfy our equation because x is less than or equal to 15. So that is why we make a solid line, because the numbers on the boundary will also satisfy our equation. So unlike in using less than or greater than, in which case we are gonna use broken line. So when I say less than 15, so the 15 is not included. It will not satisfy the equation because what we are looking for is the numbers that are less than 15. So that is why we are gonna put broken line, because those numbers that lie within those line will not satisfy the equation. It only serves as the boundary, but it will not satisfy the equation. Okay, now class, here is our boundary line using the x-intercept and y-intercept. Now, as I've said, the solution set here is a plane. So we have to shade one region here. But there's two questions with that. So it could either be our shaded region would be on this direction, or our shaded region would be on this direction. So that's why class, we had our origin as our testing point. If you remember, our testing point was our origin, which is 0, 0, which is found here. Now class, if the result of the testing point after we tested the origin is positive, then our plane must pass through the origin. So this part must be shaded. Okay? On the other hand, if the result of our testing point is If the result of our testing point is a false statement, so let's say for example that our testing point is the 0, 0, but the result was a 2 statement, then our plane must not pass through the origin, but rather it will pass through the other side. Okay? Now, since in our example, our testing point the result of our testing point is true, then that only means that our plane will pass through our origin, which is the 0, 0. So here is our plane. Okay, so as you can see, it passed through our testing point. Now, class, take note of this one. Now, um, since the meaning of this arrow is an infinity, so this also means that our plane also, or our solution set also extends to this direction. Okay, up to this direction, so long as it is within the boundary line. Also for this direction. Aside from that, also for the numbers that lie within this part of the plane. Okay, or the graph. Okay, so actually this is actually infinite, right? Now, in the module, what I have only presented is only this part, okay, the positive part. But whatever it is, it will still come up with the same answer, because as you can see in the module, this is also how that graph look like in the module. Okay, so there is no need for you to be confused. Now, let's try example 2. Draw the inequality x is less than 2y. So, first again, we must change our sign to an equal sign. Okay? Now, next, this is now x is equals to 2y. Now, next, since the intercepts are both 0, 0, we get another point by assigning real values for x. So, class, if you're gonna find the x-intercept and y-intercept here, it will result to 0, 0. Okay? Because if x is 0, then y is also 0. Because 0 divided by 2, that is 0. While if y is 0, then x is also 0. Because 2 times 0 is 0. So that's why, if you're only gonna depend on the x and y intercepts, we cannot draw a boundary line. Why? Because the x is 0 and the y is also 0. So we cannot make boundary line using that number. So that's why we have to proceed with assigning real values of x. So this is what I taught you last week, in which we can also assign real values for x instead of doing the x-intercept and y-intercept method. Okay? Now here we have, since if x is 0, y is 0, if y is 0, x is 0, so we use 2, okay, as our real value. So if x is 2, so we have here 2 is less than 2y, so that is 2 divided by 2, so we can get y as 1. Okay, so this is assigning real values. Now, next, we cannot use the origin as the testing point since the line contains the origin. We get another point not on the boundary line, say 2, 2. Now, class, since our x and y intercept are 0, 0, 0, so that only means that our boundary line will pass through that 0, 0. Unlike from our example previously, that our line did not pass to the 0, 0. But since in this case, the 0, 0 is also our point. Okay, so that means that, okay, it is within the boundary line. So it lies within the boundary line. So that means that we cannot use it as our testing point. Okay, so in the example 1, we use 0, 0 as our testing point. But since it is not allowed if the testing point is within the boundary line, or if the number is within the boundary line, so we have to find any other number that will serve as our boundary line. Okay, so just make sure that the number that you are choosing will be found on your graph. So don't choose a number that is 1 million, 2 million, because it is not found in our graph. So first of all, it will be hard. It would take too long for us to solve because those are big numbers. Okay, and second one, if we use those, so we cannot know because those are already big numbers, and our graphs actually are more or less up to 10, right? So it is impractical to use those large amount of numbers. Okay, so for this problem, we use 2 as our testing point. Now to test, just substitute x and y with 2 and 2 so we can get 2 divided by 4. Now class, since 2 divided by 4 is a true statement, then our line will pass, or our plane will pass through our testing point, which is 2, 2. Now let's see. Graph the nonlinear inequality. So we have 2 here and 1. Okay, so you can see in our table, we have 2 and 1, 0 and 0. Okay, so we have 2 and 1 and then 0 and 0. So by just using the 2 dots, we can already make our boundary line. Now, as you can see, our boundary line here is a broken line. Why? Because x is less than 2y. So if that is less than, so that only means that the numbers that lies within this boundary line will not satisfy our inequality. Okay? Now class, our point of or our testing point there is 2, 2, right? So here is 2, 2. Okay? So using this testing point, we can know whether our plane will pass through the northeast direction, or through the south, or through the northwest direction, or through the southeast direction. Now, again, since our statement is true and here is our testing point, then of course, our plane will pass through our testing point. Okay, since it is true. Otherwise, if that is false, then it will never pass on this testing point, but rather on the opposite side of the boundary line. Now, to make our plane, we have here our testing point, and so our plane will go to this direction. Okay, and next we have example 3. X is less than or equal to 4. So take note that we must use a solid line because you can see there the equal. The graph of the boundary line is parallel to the x-axis. Okay, change less than or equal to 2 equal to draw the boundary line. X is equal to 4. Okay, so class, as you can see, this is only a one variable. So if you're just even though there is no solution, if you're just to read the expression x is less than or equal to 4, so that only means that what we are gonna shade are those numbers that are less than or equal to 4. So for this case, our intercept is only the x-intercept, which is 4, since there is no y in this problem. Now to prove that x be 0, x is less than or equal to 4, 0 is less than or equal to 4, that is true, right? So this only means that our plane will pass through our origin. Okay, because using 0 as x, okay, that is actually 0, 0. So it will pass through our origin. Okay, 0, 0 is a point in the half plane and the graph is a solid line. So to graph the linear inequality, so we have here 4 as our x-intercept, and this one is our origin. Okay, now since there is no y class, so actually y there is 0. So that's why our line here is just a vertical line. Okay? So, since here is our point of origin, the statement is true, then that only means that our plane will pass through our point of origin. Okay? So, class, if you are only to read the expression, x must be less than or equal to 4. So, it should be on this side, right? It must be less than or equal to 4. And we use a solid line since it has a unequal symbol. So, that is greater than or equal to or less than or equal to. Okay. Now, here we have another example. Okay, so this is the last example for this video. We have x is less than 2y plus 1. Okay, so first step, we have to change the symbol. X is equals to 2y plus 1. Okay, so if x is 0, y is negative 1 half. So you just have to solve. If x is 0, then transfer 2y to the other side. Okay, negative 2y equals 1. So divide both sides by negative 2. So y is negative 1 half. So our y-intercept is negative 1 half. And for our x-intercept, so let y be 0. So 2 times 0 plus 1. So this is now 0. So x is equals to 1. For our x-intercept, that is 1. Now, class, for our testing point, it should be the point of origin, so that is 0, 0. So we will substitute x and y with 0. And as you can see, the result is 0 is less than 1. That is true. And so therefore, our plane will pass through our point of origin. Okay? So here we have the negative 1 half in the y and 1 in the x. Now, we draw the boundary line and we use the broken line because the symbol is less than. And for the plane, class, since the statement is true, then our plane will pass through the point of origin. So it will, the direction will be to the northwest. Okay, so here is our plane that the direction is to the northwest. Alright, so I guess that would be all for the linear inequalities in one variable and linear inequalities in two variables. So I hope you understood well. So I'm not really sure if there could be times that I got a little mistake for the usage of words, because actually it's already time check, just time check. It's already 1:42 a.m. of August 28th. So I already feel sleepy right now. Okay, so I guess that would be all for our video. And of course, class, there will be a follow-up video for this topic. Okay, for the lesson 2, there will be a follow-up video. So just stay tuned to our Google Classroom or directly to my YouTube channel. So thank you for watching, everyone, and have a good day.